2Sum explained step-by-step problem. Given an integer array nums and an integer target, return the indexes of two numbers such that they add up to the target. Example input: nums equal 2, 7, 11, 15. Target equals 9. Output 0, 1. Y. Nums 0 plus nums 1 equals 2 plus 7 equals 9. So the answer is simple definition. 2Sum means find two numbers in an array whose sum equals the target. You do not return the values. You return the indexes. Example: nums equals 2, 7, 11, 15. Values: 2 plus 7 equals 9. Indexes: 2 is at index 0. 7 is at index 1. Answer: 0, 1. Important rule. The question asks for indexes, not numbers. So this is wrong. 2, 7. Correct. Brute force approach idea. Check every pair. Check nums 0 plus nums 1. Check nums 0 plus nums 2. Check nums 0 plus nums 3. Check nums 1 plus nums 2. Java code public int 2Sum int nums int target. For int I equals 0, I less than nums dot length. For int j equals I plus 1, j equals nums dot length, j plus plus. If nums I plus nums j equals target, return new int I, j. Return new int. Enter. Dot dry run nums. 2, 7, 11, 15. Target equals 9. Check. I equals 0, j equals 1, nums 0 plus nums 1 equals 2 plus 7 equals 9. Return. Dot. 0, 1. Complexity time O(n) squared. Space O1. Problem. Slow for large arrays. Optimized approach using HashMap main idea. For each number, calculate the number needed to reach the target. Formula. Needed equals target minus current number. Example. Target equals 9. Current number equals 2. Needed equals 9 minus 2 equals 7. So we ask, have I already seen 7? If yes, return indexes. If no, store current number with its index. HashMap approach. Use HashMap. Number means index. Example. 2 means 0. 7 means 1. 11 means 2. 15 means 3. Java optimized code. Import java.util.hashmap. Import java.util.map. Public class 2Sum. Public int 2Sum int nums int target. Map integer scene equals new HashMap dot. For int I equals 0. I nums length I plus plus. Int current equals nums I. Int needed equals target minus current. If scene dot contains key needed, return new int of scene get needed I. Scene put current I. Return new int comma SSS. Input. Nums equals 2, 7, 11, 15. Target equals 9. Start. Scene equals 0. Iteration 1 equals 0. Current equals nums 0, 2. Needed equals 9 minus 2 equals 7. Check. Scene contains 7? No. Store. Scene equals 2, 0. Iteration 2, I equals 1. Current equals nums 1 equals 7. Needed equals 9 minus 7 equals 2. Check. Scene contains 2? Yes. Index of 2. Scene.get2 equals 0. Current index. I equals 1. Return. Why this works. At each index, we ask, what number do I need to complete the target for 7 period? Needed equals 9 minus 7 equals 2. We already saw 2 at index 0. So, 2 plus 7 equals 9. Return 0, 1. Visual flow nums equals 2, 7, 11, 15. Target equals 9. I equals 0. Current equals 2. Needed equals 7. Seen equals 0. Store 2 means 0. I equals 1. Current equals 7. Needed equals 2. Seen equals 0. Found 2. Return 0, 1. Complexity brute force time. O(n) squared, space, O1. HashMap time, O(n), space, O(n). Y(o(n) time. We loop through the array once. HashMap lookup is average O1. Y(o(n) space. In worst case, we may store all numbers in the HashMap. Common beginner mistake 1. Returning values instead of indexes. Bad. Return new int item. Num seem get needed. This returns 2, 7. But the problem wants correct. Return new int. Scene.get needed, I. Common beginner mistake 2. Storing before checking. Bad. Scene, put, current, I. If scene contains key needed, return new int. Scene get needed, I. If target is double the current number, you might use the same index twice. Example, nums equals 3. Target equals 6. Wrong logic may think 3 plus 3 equals 6. But only one 3 exists. Correct order. If scene.contains key needed, return new int scene.get needed, I. Scene, put, current, I. Common beginner mistake 3. Confusing current and needed. Correct. Int needed equals target minus current. Example. Target equals 9. Current equals 7. Needed equals 2. Then check. Scene contains key needed. Common beginner mistake 4. Using same index twice. Wrong answer. 0, 0. ToSum requires 2 different indexes. The optimized HashMap version avoids this by checking before storing current number. Common beginner mistake 5. Forgetting negative numbers. ToSum can include negative numbers. Example, nums equals -3, 4, 3, 90. Target equals 0. Answer. 0, 2. -3 plus 3 equals 0. HashMap solution still works. Common beginner mistake 6. Forgetting duplicates. Example. Nums equals 3, 3. Target equals 6. Answer. 0, 1. Dry run. I equals 0. Current equals 3. Needed equals 3. Scene does not contain 3. Store 3 means 0. I equals 1. Current equals 3. Needed equals 3. Scene contains 3. Return 0, 1. Best Java solution. Import java.util.hashmap. Import java.util.map. Public class solution. Public int ToSum int nums int target. Map integer scene new HashMap. 4 int I equals 0. I plus length.nums.length I plus plus. Int needed equals target minus nums I. If scene.contains key needed, return new int of scene get needed I. Scene.put nums I. Throw new illegal argument exception. No ToSum solution found. Use this when learning. Import java.util.hashmap. Import java.util.map. Public class solution. Public int ToSum int nums int target. Map integer scene new HashMap. 4 int I equals 0. I equals nums.length I plus plus. Int current equals nums I. Int needed equals target minus current. System.out.println I equals plus I. System.out.println current equals plus current. System.out.println needed equals plus scene. If scene.contains key needed, System out print line, found pair. Return new int, scene.get needed, I. Scene.put, current, I. System.out print line, after store scene equals scene. System.out print line, return new int al, then. 4. Dot. Nums equals 2, 7, 11, 15. Target equals 9. Debug output idea. I equals 0. Current equals 2. Needed equals 7. Scene equals after store. Scene equals 2 equals 0. I equals 1. Current equals 7. Needed equals 2. Scene equals 2. Found pair. Return 0, 1, unit test. Import static, org, jnet jupyter.api, assertions assert array equals. Import org junit Jupyter API test. Class, toSum test. At test void should return indexes for toSum. Solution equals new solution. Int nums equals 2, 7, 11, 15. Int target equals 9. Int e result equals solution.toSum nums target. Assert array equals new int 0, 1. Result. Say this. I will use a HashMap to store numbers I have already seen with their indexes. For each number, I calculate the complement. Needed equals target minus current number. If the complement already exists in the map, I return its index and current index. Otherwise, I store the current number and index. This gives O of n time and O of n space. Interview questions 1. What is the brute force solution? Check every pair. Time, O n squared, space, O1. 2. What is the optimized solution? Use HashMap. Time, O n, space, O m. 3. What does the HashMap store? Number means index. Example. 2 means 0, 7 means 1, 4. What is complement? Complement is the number needed to reach the target. Formula. Complement equals target minus current. Example. Target equals 9. Current equals 7. Complement equals 2, 5. Why check before putting into HashMap? To avoid using the same index twice. Correct order. Check complement first, then store current number 6. Does this work with duplicates? Yes. Example. Nums equals 3, 3. Target equals 6. Output equals 0, 1. Does this work with negative numbers? Yes. Example. Nums equals -3, 4, 3, 90. Target equals 0. Output equals 0, 2. Practice problems similar to toSum. Practice these next. 1. toSum 2. toSum 2, sorted array. 3. 3sum. 4. 4sum. 5. Subarray sum equals k. 6. Contains duplicate. 7. First unique character. 8. Pair sum in BST. 7-day practice plan. Day 1. Learn brute force, toSum. Practice. 2, 7, 11, 15. Target equals 9. Day 2. Learn HashMap solution. Practice. 3, 2, 4. Target equals 6. Answer. 1, 2. Day 3. Practice duplicates. 3, 3. Target equals 6. Answer. 1. Day 4. Practice negative numbers. -3, 4, 3, 90. Target equals 0. Answer. Day 5. Write, debug, print version. Track. I current needed. Scene, map, day 6. Write JUnit tests. Test. Normal case. Duplicates negative numbers. Missing target. Day 7. Explain the solution out loud like an interview. Use this structure. Approach. Why HashMap? Dry run, complexity. Edge cases, final summary. toSum is one of the most important beginner coding interview problems. Important concepts. Array, index, target, pair sum, brute force, HashMap, complement, duplicates, negative numbers, time complexity, space complexity. Best solution. Use HashMap. Time, ON. Space, ON. Key idea. For every number, check if the number needed to complete the target was already seen. 4. Input. 2, 7, 11, 15. Target equals 9. We find 2 plus 7 equals 9. Indexes 0, 1.